Welcome, everyone, to our AI Blueprint for the Future of Mortgage Capital Markets webinar. Um, as we normally do in our MCT webinars, we're going to wait for a few more people to trickle in here. So give us till 11:03 Pacific, and then we will get started. See you in a second. Okay, we're going to go ahead and get started. Again, appreciate everyone for joining. It is, let's see, we've got quite a bit of content to cover, so we're going to jump right into the presentation. But basically, the reason we did this webinar is for the last 12 months, we've been going down our kind of MCT's AI journey as we've trained our knowledge bases and started to look at some prompt workflows and agentic workflows. And we started to notice, that there's probably some oversimplification going on in probably in general, but also specifically to for capital markets in our industry. And so we wanted to go over a couple of the key points for especially from a data security standpoint that we encountered and that we would recommend as you guys continue to embark on your journey specific to capital markets. With us on the call here, I'm Phil Rasori, the COO of MCT. We have Andrew Rhodes, who's our head of trading, and he's been with MCT 20 years this year. And then we have Paul Yarbrough, who runs our client success group and also our data and analytics. And Paul and Andrew will be going over some specific use cases. As normally in the webinars, in MCT webinars, for those of you that have seen us in the past, I'll generally go over a high level, and they'll get down to some specifics. But look, the rationale for the webinar, we'll go over just on the agenda here. Do a quick review of the models, kind of talk about why we want to talk about the frontier models. and then go into a little bit of technical detail about large language model basics. Again, there's we expect there to be a huge range of knowledge on the line here with regards to AI. Some of you guys have been doing are deeply understand retrieval augmented generation, fine tuning methods like that. Some of you are probably still fairly new to AI. So for some of you, this will be a little technical. For some of you, it'll be fairly basic, but hopefully we can cover all bases. Then we'll go over some of the products that we use. Not that this is a sales pitch by any means for AWS, but just the reason we like how the Titan embedding model works and how Bedrock, how their partnership with some of the AI firms out there, how we like that from a proprietary data standpoint and a data security standpoint. Then we're going to move into more of what the title is of this webinar is kind of our blueprint of where we think it's essential to design workflows, especially agent workflows. Everybody who is following the news in AI knows that 2025 is supposed to be the year of agents, and so we'll talk a little bit about the difference of what we've found to be prompt workflows, which are conflated a lot in the industry versus true agent workflows. And then we're going to go through, like I said, Paul and Andrew will go through some specific use cases that we see for capital markets. Again, I think there's a little bit of just in general with AI, a little bit of an attempt to jam a square peg into a round hole. Sometimes there's at least for the current capabilities of AI as they exist right now, there's good fits, there's good use cases, and then there are not so good use cases, at least for where the technology exists right now. And then we'll close out by just our recommendations for responsibly using generative artificial intelligence in specifically with capital markets. And of course, the two main concerns that we should all have in capital markets are basically number one, data security, but also accuracy of output, right? Because there could be substantial things can go wrong if in fact we're not getting accurate results from our AI models. So moving into the rationale, look, I think we can all agree that AI will play a dominant role in capital markets eventually. Right now, there's some specific use cases that are going to change the industry, and what we found internally and I'll talk about knowledge bases and how we trained our product, which I'll talk about in a second. But what we found is it's really going to cause a distribution of expertise where at your fingertips, you as a customer of MCT or any hedge advisor in capital markets, you'll have at your fingertips truly the answer to any question in the model, and that will have dramatic effects on how frankly us as a hedge advisor interact with our customers, how our customers interact with pipelines, with their pipelines, make decisions on their pipelines for risk, from a risk standpoint. But there's no question that where without any improvement to the current AI models out there, the expertise distribution is there. It's already happening. And we'll get into that on how we've just released today that functionality. And then eventually, those of you that have been again following the using some of the products out there that are just recently released. Mainly the category that I'm talking about now is the reasoning models, or the deep research models. And those will eventually, their ability to reason and methodically go through all of the steps that are required to, for instance, calculate a hedge recommendation. There's a lot of information to mull over when you're looking at a hedge recommendation, and Andrew will talk a little bit about that later on in the call. But the bottom line is that from a hedge recommendation standpoint, eventually this will more than likely be a superior way to generate a hedge recommendation using a reasoning model to assist you with your process. And then probably the main reason for this call is, we want to talk through the criticality of protecting lender borrower data, and what to look for when you're talking to vendors about that may be using some off-the-shelf products. And then again, we believe, and as we've went through our AI journey here, we believe that it's important for the entire company to be fully aware of the data flow, and that goes to the embedding process, to what we'll talk about later, retrieval augmented generation. But everybody to be understanding what's happening, everybody to, especially the subject matter experts, to take part in the creation of the knowledge base. And so we'll talk also about agent and prompt workflows in the coming slides as well. So the current frontier models, these are really household names. The third one down, obviously, being the biggest name out there, OpenAI, with ChatGPT and some of the O1 model, and what they're going to be releasing, the O3 model. Google Gemini is a big one, and then Anthropic, and we'll talk about why we do this, why we have used them in subsequent slides. But Anthropic is the other group out there with the Claude family of models, and they definitely, we like where they come from a standpoint of AI safety, and their focus on both safety and security. And then there's a couple open source models, the Facebook Meta Llama models, and then the DeepSeek model, the Chinese company that made a lot of news a couple of weeks ago. The reason I bring up the open source models is that, if you look at these models right now, any vendor that you're using, or frankly any model that you're going to be using, if it's a what they call a frontier model, a top tier model, it will be based in one of these models. More than likely, it's going to be an API relationship with either Anthropic, Google, or OpenAI, and because training the open source models definitely takes some compute cost. So it's usually most cost effective to use an enterprise API relationship, and that's where we want to be. We want to really focus on the process of what's being employed, the data transfer that's being employed. So again, I'll get to that a little bit down the road here. And I apologize for moving fast. We do have a lot to cover, And I would just say at the outset, for those of you that have any questions, we will put this recording will go out to everybody who registered for this webinar, along with contact info. So bear with me on the next couple slides here. This is just some quick definitions and kind of process overview of large language models. I should have said this earlier, for the clients on the line, a lot of this is going to be review. Obviously, we did the client webinar a couple weeks ago when we talked about the release roadmap, but there'll be some additional stuff in here as well. But these couple slides here will definitely be a review from that client webinar. But basically, one concept to understand is the knowledge base in a large language model. This is the data corpus, on which the model's been trained. So for these frontier household name models like OpenAI's models, they're obviously training, and Google, they're training on the entire Anthropic, all these large household name models are training on the entire corpus of data out there that they have access to on the internet, right? Mainly data that's not behind authentication walls, but this is the entire data corpus that the LLM has been trained on. We'll talk about the retrieval augmented generation and how that will allow AI to provide very context-oriented and very accurate answers, specifically for in our case, in the sliver of the industry that we're in hedge advising. But then so a token is the other concept that we want to talk about. This is basically the unit of text that is basically the basic unit of text that is broken, that the large language model processes. And basically it will almost think of it as a syllable, and it will average to about 0.75 words. And so the large language model will convert the training material into tokens, into numbers, and then it will convert your prompt into numbers, and we'll talk about that in a second. But basically, a vector is assigned to each word, and so there's a token ID, and that's assigned to this group of numbers. That's a vector, and that allows the large language model to look for that semantic similarity. So if we think of I've got here as an example like pool and lake, they would have similar vector values for like the fluid, the aspect that they're both fluid or they're both water, but they would have different values for size and chemicals. And so these LLMs are generally using 1,024 dimensions. So there's all kinds of semantic kind of definitions to each word, and that's how the magic is created, where the model is using these dimensions to basically predict the next word. And so from a data security standpoint, the vectors can't be reverse engineered to their original words, which is really nice for a vector database standpoint. But with regards to the kind of how that interacts with your prompt when you use a ChatGPT, you will enter your question or your query into the system, and then basically the vectors basically what will happen is there will be a system prompt that comes along with that, and that will basically have additional tokens with it. And basically the point that you trying to get across here is that you can actually put into most of these models the equivalent of a full novel into the prompt. And so in this case, in the case of Claude Sonnet 3.5, which is the model we use, you can put in about 150,000 words, which comes out to about a full book that you can put in. And so that you can put a lot of information into this prompt. And so the general LLM process, the training process, is basically these knowledge-based documents are fed into an embedding model, and the embedding model assigns tokens and vectors to all of the words in the knowledge base. And then these vectors are stored in what's called a vector database. And then so when the user puts information into the puts you as the user, you ask the model a question, the embedding model will tokenize your question, and then it will hit the vector database to look for similarity, mathematical similarity, and then it will place those results into the context window of the LLM for the large language model, and then all of that will be sent to the large language model. And then in the normal process, there will be these models are sanitizing the output back to the user for a variety of reasons. Obviously, that there's not a bad or dangerous answer, and you guys have obviously heard all about that. But basically, so what happens? This is the general large language model process overview. What happens when we use this current training, basically this general training here, and we ask it something specific about like our platform MCT Live, because MCT Live is behind a paywall, or I shouldn't say a paywall, a authentication wall. The models don't really know what's going on. So when you ask this question, this is just online here. You ask this question to Claude Sonnet. It says, the question, how do I add rate sheets in MCT Live? It correctly says, basically, I apologize, but I don't have any information about that. ChatGPT put the same question in, and it kind of hallucinates an answer. You can see that it understands that kind of what is being asked, but it's not a correct answer. And so how do we make that answer correct? What we do is we use what's called retrieval augmented generation. And so what we do there is we create our own specific knowledge base, and a lot of you guys on the line obviously are doing this as well. And then you embed this knowledge base into token IDs and vectors, and then these vectors are stored in your vector database. And then the same process when you as the user, when you ask it a question, and it goes into the embedding model, and basically the embedding model is going to run, this query is going to run up against the vector database using the large language model, and return the basically context chunks, basically generated context that is what the model sees as similar to your question. And then it's going to take all of that information. And I talked earlier about how big that prompt can be. You don't see the prompt, but it's going to take all of that information, it's going to put it into the prompt. So now it's giving the model all of the information. And so, but the important point to understand here is that the knowledge base is stored locally, and only the generated chunks, those specific information pieces, are sent to the LLM. You're not sending the entire data set to the LLM, which again, as I said earlier, you have the ability to potentially send a full novel into that context window. So there is some cases where all of that information is sent to the LLM. So that's more from a proprietary information standpoint that you want to be careful, and you want to look specifically at the how is a knowledge base being used, is retrieval augmented generation being used, and then also important to understand the embedding model as well. So all of the knowledge base documents, all of that proprietary information is fed to the embedding model, regardless of what what knowledge base setup that you have. And so all of that, if you're using an embedding model, or your vendor is using an embedding model that is sending all of that information to the large language model, that to that company, that all of your proprietary data is potentially getting trained on. Obviously, if there is a enterprise relationship, then you have some security there. But it's important to understand that if there is benefits obviously to using a specific knowledge base and using what's called RAG. Again, that's the short for retrieval augmented generation. There's benefits there because you're not sending all of your data to this model, but you need to make sure that the embedding model is a local model and not and doesn't sit at the frontier lab that can be trained on. So going through now, we'll get into a little bit of the process flow here. Basically, if we look at a user here, we're going to send our prompt in. It's going to go through this embedding model, and then the tokenized prompt is going to be matched against this vector database, and then that is going to be sent to against our knowledge base. In this case, in our case, we use this. It's an AWS product through Amazon Bedrock. This model is going to look up, again, this knowledge base is locally on our servers. It's going to be looked up, the context around what our prompt was, what our question was, is going to be looked up, and then it's going to be sent to the large language model to use the magic of the large language model and basically give that semantic similarity, and then send it back to the user in a readable form. Down here at the bottom of this graph here, I have basically just the training process, again, where we're embedding these documents, and then loading them into a vector database. Again, this is just a RAG process flow, and this is our process flow for MCT Live. To date, our client base, we released what our model that we're calling Atlas AI, and basically, again, it's when you have a question, your questions go into this embedding model, and then it's running up against our vector database, and it's looking for information that's been loaded regarding your question. So if we look at why do we use retrieval augmented generation, if we look back at this question that was completely answered incorrectly by the retail chatbots. If we look at that was the general question. If we look at how the question performs when we on our research platform, where we put our question in and it runs up against our retrieval augmented generation vector database, you can see that it provides a much better answer. And this is the exact same model. So it's the exact same large language model that answered. I apologize, but I don't have specific questions. But again, because the knowledge base is sending information into the prompt, it's able to answer correctly. And these are these context vectors. Again, this is the context that's been pulled. We have there's a text file that explains how to do something in MCT Live, and we're basically the model is through semantic similarity of the vector database. It's pulling this context and then putting it in, and that's enabling the model to answer correctly and consistently. So specifically to the reason I wanted to talk a little bit about AWS Bedrock is really just the third bullet point down here, where they have a partnership with Anthropic, where they escrow their large language model at AWS, and they don't have where they don't have access. Anthropic, the large language model company, doesn't have access to the data in the model. And that's the same way with Titan, which is the embedding model. I talked about that being very important. In this case, that the Titan embedding model is in our what's called a VPC, a virtual private cloud, and that resides again in our local setup, in our AWS environment, and doesn't go out of AWS. So although we're being careful, obviously, and we'll talk about that in a second here on, we're being very careful on what we send the LLM, we can be confident that the LLM company is not seeing the data, as long as we trust AWS here. So if we look at basically some prompt agentic versus prompt workflows, I'll go over this. I know there's a lot going on in this slide here, but basically there's I talked earlier about how there's a lot of conflation of agent workflows and prompt workflows. And so this is a real a simple example of the user interface basically being an agent, where it's going to decide based on you as the user asking a question. It's going to decide whether or not you're asking a question that makes it go to the chatbot. In our case, our Atlas AI chatbot, and then in that case, the chatbot will use the normal RAG process flow that I described, or the agent, through using its own RAG process. Again, the agent is going to be trained just in the exact same way that we talked about earlier. It is going to decide based on the question. So let's just say that I had a question of, what's my hedge position versus how do I make a trade in MCT Live. If I asked it how to make a trade, it's going to go to the chatbot and it's going to look up the knowledge base on how to make a trade. If I asked the model how, that I wanted to see what my coverage is, that's where the agent needs to come in. And so the agent decides to make a function call, and then that will actually, there's no AI involved here. That will just call a normal function that is called if you're in our platform. And again, I'm using our platform as an example, but this is really any setup. If you are in our platform, you are going to be making these when you click on a coverage a coverage position, you're going to be making these exact same calls that the agent is. So the point here is that this is really just a outside of the initial decision of what to be made, of what to be done. Everything else is basically standard, the standard execution of the platform. And so if we look at what would a true agentic workflow be, I'm using the auto hedge. This is the Nirvana, and for those of you not in capital markets on the line, this is kind of the Nirvana of what everybody wants to get to. And we are currently testing this. It's definitely not in production. It's definitely I would say it's not going to be in production for a while. But basically what you can do is, we have this term called optimal coverage, and in this case the user would ask the agent, basically say, get me to optimal. And so in that case, that would be the first data transmission. The second would be the agent first needs to call our advisor function, which we have, and that's currently what our traders kind of, again, test with. We don't use this for clients, but this is what's currently in testing. There'd be an agent call, and then the third transmission here is an API call to MCT live. The response is number 4, and that basically will get the position and the recommendation for what needs to be added from a coverage standpoint. Number 5 would be a response to the Atlas Advisor response to the agent user, basically saying that, let's use the example of a million UM36s need to be put on. And then that's where true agentic workflow would occur, is that the agent could then call our trade function, and then through our relationship with, I don't have it on this slide, but through our relationship with Agile Trading Technologies, we can electronically execute a trade, and then that would basically, the trade response would come back to the trade function. That would give the agent user what has been executed, and then you as the user would be told. Obviously, there's a lot that goes on, goes on there, where there's a lot of questions as to how the trade is executed, how the trade is picked. But that's definitely that is something in process. But I wanted to show this because this is a true agentic workflow. But the reason I've been basically showing you guys these diagrams is the main diagram, the main style of workflow that everybody needs to get to from a standpoint of data security when it involves an NPI or even proprietary data request, but especially MPI. And this can be something involving whatever it is involving MPI. It's important to understand that you can still use this functionality in a responsible way. And so if we look at what would happen here, there's an MPI data request that goes to the agent user, and then there is a function call for NPI data, and that comes out. That's just like if you were to pull a bunch of loans, loan data, or let's say you wanted a loan officer pull through by name. Obviously, that's MPI data that would come through, and then it would be returned to the function. But the point to understand is, in the previous slide, I've had the user, you as the user, talking directly to the agent, but that's not really what happens, right? You talk to the user interface, and so what we can do is we can skip basically the LLM when we respond with that data. Now we can have what we call a contextual response, where it can give context around the data from the large language model. It can use its knowledge base to talk about the data. But the point is, we can give the names, we can give the NPI data, and directly skip the LLM altogether. And so that's really the main kind of workflow that we at MCT have arrived at when we're talking about data that we don't necessarily want, dealing with data that we don't want to send to the LLM, but we still want to get the benefits of the LLM and the benefits of agentic, of workflows. So with that, I'm going to pass it over to Paul, and he's going to take us through some specific scenarios that we're looking at.
Yeah, thanks, Phil. That's a ton of information, really good stuff, though. Good to look back on how we got there for the last 12 or 18 months, and seeing all the work that's gone into it there. So kind of with the foundation of everything Phil just presented on, bringing this into like an application or how we would take all of that information and what it looks like to the end user. So within MCT Live, our capital markets platform here at MCT for our hedge advisor clients, we have, first off, if you're just looking at what we've trained the model off of. So we've trained the model off of several how-to guides on how to use MCT Live, several kind of transcribed videos of a user walking through the different functions in MCT Live, and here's some some basic questions that you can see as our screenshot here of a user asking Atlas, how do I run a pull-through analysis, or what is status fallout, referencing a specific word or phrase in MCT Live, asking what is that, what does that mean, and or how do I sell loans. So having it walk you through step-by-step process to show you how to follow a task. So it is very interactive, so you can ask it like, okay, I uploaded my loan numbers, that's something specific to our platform, to all the way down to, okay, how do I commit? And again, this is based off of our subject matter experts here at MCT, kind of walking through step-by-step how to do these certain things, walking through definitions of terms or phrases in MCT Live to train the model. So that's a very specific, or these are very specific use cases on what the a chat bot will do, or what based on the training we have. So, and soon enough, we will have video references as well, so where the chatbot can reference a video, so you don't even have to read the response, you can follow along in a video if that's better for you. Or and then we also have agents coming to this as well. So where Phil was just talking about that agentic process, a little different than what we're training the model off of you know, several 100,000 words of text to train the model, but then we move into kind of the agent process. So an example of that is on our next slide here, Phil, where we want to be able to ask it questions like, hey, what are my par rates? You know, a very practical question on for somebody that's looking to value a pipeline, do a mark to market, or run a best execution. One of the components of servicing are par rates, right? So kind of being able to say, what are my current par rates that are embedded in our system, and have the model spit back out like, these are your current par rates. So you can see in our example here, it's actually going out and calling a function within MCT Live to come back to you in real world language. And so this is an example of how we're using kind of this agentic process to get data out of MCT Live and put it back to you in this kind of human language, if you will. Kind of enhances the user experience, more prompt responses. You know, today we pride ourselves quite a bit on customer service and our response time to questions like this, or questions on how to, and sometimes you may not be in the place where you can ask those questions or whatnot, but you are in a place where you can kind of ask the chatbot, and so you get this enhanced user experience. And it's very dynamic as well, because you can see here our intended process on something like this would be to give the user the ability to not only ask what's in there, but in the near future also make effective changes in there too. You know, but we're being very careful with that, because while the agents and the functions we're calling will change it, we also want to make sure we're logging those changes and whatnot. So that's where we're coming at there. And then obviously very secure and controlling that data process through all of the ways that Phil just kind of presented on how we're kind of protecting the data as well. So, and then on the next slide here, it's going to go back to a previous slide that Phil was kind of referencing. And you'll notice on that top line, kind of in the middle of the screen, where it says pull through summary function response. That's a key piece of the process there. And so you can start all the way over on the left, and you see the MCT Live user will plug in a question, and it may be something related to pull through. But you're wanting very specific pull through for maybe a particular loan officer. So that's something that's already we already have in MCT Live, but we're imagining a world where you can just say, instead of like drilling down to a pull through analysis, where you will be able to say, all right, give me this loan officer's pull through, and you're drilling down to that loan officer in a drop down, you're going to simply ask it a question. May I have a pull through analysis for this loan officer? And so the model, the LLM model, is then just ciphering what you've asked it. Like, okay, now that it knows what you've asked it, it's going to call these functions, and it can call these functions without ever actually sending any of your LO or borrower data to the bigger LLM model. It's really just calling a function that's using the MCT Live information to push this back into the chatbot. Again, none of that information is ever actually sent to the LLM model. All that the LLM model is doing is deciphering which function to call. So that's what this chart is doing. And that top line there, where it says that pull through summary function response, again, that's the key one here, where we're skipping the whole agent user and LLM model and just going right back to the information, or to the UI to give the information back to the user asking. And then on our next slide is kind of what that would look like. So can you give me a pull through analysis for my loan officer, Ben Itkin? So Ben Itkin here, great loan officer, giving 85% locked fund pull through. Breaking it down, the LLM will then, just like it does in our user interface today, now this is kind of giving you text and describing what kind of pull through they have. So they have a purchase pull through of 92%, a rate term pull through of 82%. So and some other stats available. So really just transcribing what we have in our model today, and then putting that back into kind of human language, and walking you through some other steps there. Interested in more stats, comparing the analysis. So these kind of things where we're looking to kind of roll out to where you can have that ability to have the conversation with the Atlas AI, but then also like who's having that conversation, right? Like, so if it's maybe it's a client admin that should have access to this versus maybe it's a junior analyst on the desk that maybe shouldn't have access to it. So that's what we're looking to push here soon. So with that, I will pass it over to Andrew, who will go more into details on models and hedge specific uses for this.
Yeah. Thanks, Paul. And yeah, it's a lot of information to take in as we've gone through a ton of different slides, but I think we're trying to make it consumable so you guys understand exactly how the process flow is working on our side, so you guys feel comfortable about what you guys are looking at. And as both Phil and Paul have mentioned, this is all based off of internal data training the model. So one thing that I think we always pride ourselves on here at MCT is trying to educate the client on what they're looking at, right? What does $1.5 million in exposure mean, and how does that really translate to a locked desk person, and how does that translate to a senior kind of capital markets person? So what we wanted to do is we wanted to go through the education process and kind of make sure that we're defining everything on the platform to make it consumable for any user. So you could go in there and just type in a question. I put these questions in the other day, and you could see the response is appropriate. And the thing about we're continuing to train the model based off of what the traders, the collective trader group have kind of input into the training documents. So we're continuing to feed that to make it more robust. But I think what we have is with this solution is already pretty well defined. I think if I tell the ask Atlas what does my $1.6 million exposure mean, it gives me a pretty appropriate response on needing to add some additional positions because there is some value at risk with that kind of exposure. So I created this slide because I wanted to show both the there's just multiple ways to ask the same question, and we're getting as I'm sure all of you guys have done, gone into a chat bot, typed in a question, you get a response, you type in the same question, you get a different response. So it's giving you the same answers in different ways, and you're able to ask it with natural language the question that you want to know, and it's providing appropriate answers. So we're continuing to build on and develop this to make it appropriate and to make sure that everything that is coming out is educational and appropriate. So another kind of point along the same lines is looking at like, hey, this is starting to go into the workflow that Phil was talking about earlier, but this is just a basic question like, hey, what is the appropriate coupon to adjust my coverage? And it's like, okay, well, let's kind of think through it. What do I need to look at? What do I need to assess? So it gives you a couple different bullet points on how you should be determining what is the right coupon to trade and how should I look at modifying my coverage, right? So this is going to be, like I said, we're going to continue to build on what we have, but I think what we have is pretty robust for where we're at, and it's only going to continue to get better. So I think Phil, if you want to go to the last slide, I'll kind of breeze through these real quick. I think this last one is kind of specific to that last, kind of goes back to the last slide, and what Phil was talking about earlier with the kind of the workflow on coverage. So I put in this prompt. This was actually earlier today. Here's my coverage on a coupon basis. What trade should I do to minimize my dollar exposure? And so this would be the prompt workflow that Phil was referring to earlier, where it's kind of taking some high level information and giving you some feedback. So, it's saying I should trade 1.5 million of the 5.5s, but alternatively, I could trade 2 million or 2.25 of the UM6s if I'm worried about liquidity. So it's already taking that step in kind of giving appropriate responses in terms of how to manage the position, and this will kind of lead into that agentic workflow that Phil was talking about. Kind of going through the whole process, and I think as you kind of go down in the explanation, I think it's great that it has those key considerations. Because those are essentially going to be some of the guardrails that we're going to have in place with the agentic workflow. Only trade liquid coupons. You have minimum increments per position. You're going to have a minimum dollar threshold. There's no reason to trade. Maybe I don't want to trade a 5 right now because I don't feel like they're liquid enough and I don't feel like I have enough production on. So these are all going to be inputs into the agent to workflow to provide the appropriate recommendation. So I think it's going to become more defined as we kind of move down that path. And I think providing duration units on both the loan side and the hedge side on a coupon level, that all is going to flow through and provide the model with appropriate information to make the appropriate recommendations. So that's where we're headed, and I'm really excited about what the next couple months are going to bring, because we've been like Phil said, we've been working on this for a long time, and we're excited to kind of get this out to the client base and help kind of push it forward.
Well, thank you, Andrew, and thank you, Paul. As I said at the outset of the call, Paul and Andrew are definitely bringing home as far as what specifics on what our technologies are working on. How they're used specifically in capital markets, and I just kind of talk about at a high level. But just to close up here, I think the key that we want to get across, and this is for for those of you on the call, and I think probably a lot of you do, for those of you that believe that AI will continue to improve and continue to become more and more of a factor in pretty much every aspect of our lives, but especially how it pertains to capital markets. It's really essential from a professional standpoint and frankly a personal standpoint to understand the process, right? Understand the training process, especially when sensitive data is involved. Understand the data flow, like in retrieval augmented generation, and also understand that you're as you start to design these workflows, they can be designed in a secure fashion, even when you're dealing with highly sensitive data. But I didn't have a chance to talk too much about agents in general, and kind of use cases for agents, but they will continue to proliferate, and I think that that's going to potentially accentuate some of these data risks, and so knowledge of the process is going to be extremely important. And then again, like I said earlier, if you're using RAG, retrieval augmented generation, just understanding the embedding model. It doesn't matter if your knowledge base is local and secure if you're sending all of your information to be trained on as it's being tokenized using that embedding model. And the last thing I just want to stress is as AI stands right now, with regards to capital markets, it should always stand behind you in your capital markets decision making, your trading activities, your hedge recommendations. It should always stand behind you. It should never stand in between you and those recommendations, in between you and those capital markets activities. And again, like we said at the beginning, the best use case right now by far, indisputably, is the ability to distribute expertise and give everyone access to expertise. And that here at MCT, we're excited about that because we've always been into transparency and education. So like Andrew said, we're really excited for the future. And we will, obviously, for the clients on the line, as we had said on the previous webinar, we'll be doing a lot more webinars coming up as we start to release more of this functionality. With regards to public webinars like this one, we may be we'll probably do another one here in a couple months regarding as we move more down the agent path. But I really appreciate everyone's time. I hope you guys all felt this was valuable, and we will hopefully see you soon in a future webinar. Thank you.